Hey, Chem 20, 120 was something like that. Anyway, who cares what the number is? We're here to do some chemistry. Chemistry on the board. Like a child doing its homework. Finally, I'm doing my homework that I was supposed to do way back when I took this class the first time. But here it is for you. So we have a problem on the board. It starts with sulfur 8, right, which is 8 sulfur molecules plus 8 oxygen molecules yields 8 sulfur dioxide molecules in the gaseous form. This is what stoichiometry is, right? We say whole number ratios or stoichiometric amounts. So 1 mole of S8 plus 8 moles of O2 yields 8 moles of SO2. So that's the stoichiometric part. We've got to remember those ratios. So for every 1 mole of sulfur 8 we use in this reaction, we burn up 2,368 kilojoules of energy. Delta H, change in enthalpy, which is a change in energy, right? We recognize the units kilojoules as energy change. So it's a negative energy change, so therefore it's an exothermic reaction. Whenever you see a negative delta H in kilojoules, it means it's exothermic. The opposite is also true. When it's a positive value, it's endothermic, or it absorbs energy. So exothermic means that when the two reactants combine, they release energy, the product's in a lower energy state, and there's energy out in the universe, leading to a release of 2368 kilojoules. So, given that, let's see what happens when we have 25 moles of S8. All right? We have 25 moles of S8, and we know that for every 1 mole of S8, we use 2368 kilojoules of energy. So, the relationship then becomes to find out how much energy that is, minus 2368 kilojoules per 1 mole S8. You do that math, and you get minus 59,200 kilojoules. Now, we only have 2 significant figures here, right, with the 25 moles. So that becomes 59,000 kilojoules for your final answer. Now let's look at another way of doing this problem. Let's say instead of giving us 25 moles, they say we start off with 275.00 grams of S8. How much energy, or what's the change in delta H of this reaction when you start with this? Well, the first thing to do would be say, okay, we have to figure out what the molecular mass of sulfur 8 is. Not sulfur, not 32.6, but 8 times 32.6 to find out the number of moles. So that happens to be 1 mole of S8 equals 256.40 grams. Now that we're in moles of S8, we come right back up here to our other conversion factor, the delta H, and this is too close together, so 2368 kilojoules per 1 mole S8. So let's do the calculation on this problem. Once we do the math, we get 2543 kilojoules of energy for delta H, remember. So when we run this reaction with 275.00 grams, we do the conversion to moles, then we do the energy conversion to kilojoules per mole, we get 2543 kilojoules. One last way of doing these problems, and there's just enough room on the board to do it. We're going to look at a product instead. 150 grams of SO2. Remember, now this is only 2 significant figures, so our answer is going to have 2 significant figures. So we look at the reaction, and we're looking at SO2, and we're going to make 8 moles of SO2 to get this conversion factor. So first we have to convert the grams of SO2 into moles of SO2. And I just happen to have that number with me as well. So 1 mole SO2 is 64.06 grams of SO2. All right? And now we do the conversion factor. 2368, and remember it's exothermic, so there's a minus sign, kilojoules per 8 moles of SO2. Because the stoichiometric ratio to get this much energy is 8 moles of SO2. That's what our ratios, whole number ratios, tell us about this reaction. And since we're looking at the product, to get this amount of energy to use as a conversion factor, you have to have 8 moles of product. So, when we do that math, we get 693 kilojoules. And that's a minus. So is that. How dare you let me go do that without telling me. So minus 693, but there's only 2 significant figures. So that answer, to get full credit, becomes 690 kilojoules. Thanks for your time. So, if you're paying attention, you'll notice that when I did my final answer, I didn't carry down the minus sign. Be sure to carry down the minus sign. Always check your answer for rationality. 690 kilojoules would be an endothermic reaction. So we need the minus sign there because this is an exothermic reaction as evidenced by the minus sign for the delta H conversion factor. All right, now thanks for your time.